Hi, let's solve today's daily challenge, that is least number of unique integers after k removals. In this question, we are given an array of integers and an integer k. And we need to find the least number of unique integers after removing exactly k elements. So let's first understand what we mean by the question. So we are being told you can remove how many elements? 3 elements. 3 elements, but unique elements? No, not necessarily, right? But after you remove these k elements, you should be left with the least number of unique integers. Okay, all right, so let us see in this array. If I try to remove, let's say I start with 4, 3 and 1. Okay, so I can remove any 3 elements here. So here notice, even if 2 elements have the same value, they will be counted as different elements. Okay, because this is one element, this is another element. So if I remove these 2 elements, then my k would reduce by 1 because I removed 2 elements and it was 3, right? So I hope you understand that here we don't have to remove unique elements, but we have to remove k elements, and they can be any element, right? Even if it is occurring more than one time inside of the array. All right, so that we understood. So let's say I remove 4, 3 and 1. So what will I be left with? I will be left with 1, 3, 3 and 2. So out of these, what are the unique integers we have here? We have 1, 3 and 2. So here I can see I have got 3 unique integers after removing k elements. But we want to know the least number of unique integers. All right, so let us try to remove one. So let's try to remove 1, 1, 3. Okay, if I remove this, I will be left with 4, 3, 3 and 2. Now again here, the unique elements, if you see, is 4, 3 and 2. So 3 unique elements. But what else can we do, right? Let us say that I remove 4, 2 and let's say this one I remove. So after this, my array would become 3. Let me take another pen. This 3, 1, 3, 3. 1, 3, 3. Right, here let's write the unique elements, that is 1, 3. Okay, so we have gotten lesser unique elements than we got in these two cases. Okay, let's see if we can get one unique integer after we perform the operation. So it would be much better if I write it in sorted order, then it will be much easier for us to see what's happening, right? 1, 2, 3, 3. Okay, 1 is twice, right? 3 and 4, right? These are the elements. Now here I have to see if I can get, lesser unique integers than this that I've gotten here. So let us try. So I can see that another thing that I can do is I can remove 2 and this 3 and 3. Okay, not another 3 but 4. Okay, so I'll get 1, 1, 3, 3. So again, similar kind of an output I have got. And again here I can see 1, 3 are unique elements. So again 2 is the answer. So I can already conclude. Now if you try to go ahead and try other combinations as well, you will only get 2 here. Okay, so that's the thing. So 2 is the least number of unique integers that we can get in this case. Okay, so now you can already observe, right? After I try to perform the operations, you might have already observed that if we want in the last unique integers, right? Because I can remove any elements, right? So I'll avoid those elements which have higher frequency, because in that case I'll be consuming more elements from k integer, correct? So instead of that, if I take the elements with the least frequency and remove them from the array, then the chances increase that I will, in the end, after removing k elements, I will be having least number of unique integers. And that definitely makes complete sense. Correct. So here, what I'm saying is, you take the frequencies of these elements, okay? So I take 1's frequency, which is 2, 2's frequency is 1, 3's frequency is 3, and 4's frequency is 1. So now here, I said take those elements first who have less frequency. So I can see 2 has 1 frequency. So remove it from k. Okay, so I consumed one element here. then remove this. I consumed another element from here. Now I can either remove one of the ones or three of the ones, right? So because I can remove only one, I will still be having 1 3 left, right? So that is the unique number of integers that I will be left with, and it is the least number of unique integers, correct? So that is basically the approach of the problem, right? If you observe this, then the problem is quite easy afterwards. Okay, so that is basically what we have to do in this question. We have to, you can sort the array, or instead we can also use a priority queue, right? So in this here in this video we are going to solve it using priority queue. Now what is a priority queue? See, let me first discuss the whole flow, how we are going to solve it. Let me first again write the logic, and then we will see how we will implement it. So what we are going to do is, we are given this array, we'll iterate it, and we'll form this map. Okay, we'll form the frequencies of all the elements inside of the array. So I will get, in this case, this, right? Let me write again. Okay, and for 4 we have one frequency. After creating this map, what I want to do is, I want to remove the integers with the least frequency first, because that increases my chance of having least number of unique integers left inside of the array. Why? Because see, we are given this k number which is fixed, correct? So if it is fixed, then if I consume elements with larger frequency, in this case if you see, if I'm given here the array is written, right? If I remove, let's say, these three elements, so in the last, the unique integers are 1 2 and 4, so it is not helping, right? Rather, if I take the lesser frequency ones, right, so you can already see two numbers are already removed from the array, right? So that is the logic behind it, right? Because in the last we want least number of unique integers, so that is why I'm saying the numbers with lower frequency we have to remove first. So how do we identify the numbers with lower frequency? For that, we can create a priority queue. And after creating this priority queue, first let's discuss what a priority queue is. For those who don't know, priority queue is a type of queue in which we have priorities to the elements, right? So here priority can be according to largest number or the least number, or even you can make your own function which describes the priority of a particular number. But we usually deal with min priority queue or max priority queue. So min priority queue basically means that the value which is minimum will have more priority, and hence it will be present in the front of the queue. So inside of the queue, this element has most priority and is minimum number, right? So second large number than this number will have less priority, and so on. And the exact opposite is for max priority queue. So I hope you've understood what priority queue is. So in this case, as we want lower frequencies first, right? I want lower frequencies first. That means I'm going to use min priority queue in this case. Okay. So how will it be formed? I'll be taking a pair, right? Inside of priority queue, I'll be inserting pairs. Pairs of what? Frequencies and the element. So as you are already aware, a pair in C++, how it stores values, and it always compares the value from the first value and then the second value, right? So that is why we will take the frequency here first, because frequency matters more to us, right? We need to remove the elements with this frequency first. So inside of the pair we'll store frequency, and here the element. Okay, here we are going to store the element. So how will the priority queue for this particular test case look like? Let me form it. Okay, it's a priority queue, right? All right. So here's the priority queue. So as I said, the lower frequencies will have more priority. So here, because 4 and 1. So see, this is what the pair for all of these values look like. 1 2, 1 4, and 3 3, and 2 1. Okay. Now according to the frequencies, so here you can see inside of the pair these are the same value. So the value which is lesser here in this case, because this is a min priority queue, that will be stored first. So here the first values inside of the priority queue will be 1 comma 2. Then we'll have 1 comma 4. Then the next value will be 2 comma 1, right? And the next value will be 3 comma 3. So here you can see the priority of the element which has lesser frequency, right? Least number is more. So this is min priority queue, right? So now what I will do, inside the priority queue, we can use the top function to get the front element of this queue, right? So I'll get this element. So I'll remove this from the priority queue. I'll pop this element and also decrease its frequency. So here the frequency is 1. I'll remove this frequency from k. After that, I will come here and here k is 2, right? K is 2. And I'll remove this from the priority queue. Now k will become 1. I have removed this frequency. Then I will come here. Right here you can see that the frequency is more than k is, correct? So what we'll do, this is the case where we are ending up with this element, right? We don't have to iterate more in the priority queue because this is the last element, and we'll remove 1 from this. So what we'll do, we'll remove this from the priority queue, and what we'll do, this is the condition that we will have to handle where k minus f is becoming negative, right? F for frequency that is inside of the priority queue. So it is less than 0. So obviously we cannot have k less than 0, right? So what we'll do, we'll say set k to 0 and also push the frequency remaining for this element inside of the priority queue. So we'll do pq dot push and we'll push what the frequency now is. So the frequency will be f minus k, right? So 2 minus 1 comma the element, so the element is 1. So now the final priority queue would be looking like, 1 comma 1, right, and 3 comma 3. So these are the elements of the array that we have inside the priority queue, right? Now the size of the priority queue will represent the least number of unique integers. All right, so because already we know all these elements are unique only because they are contained within their frequencies, right? So here if I simply output the size of the priority queue, I'll get my answer. So I hope now it is very clear to you. Let us quickly go ahead and code it out, then it will be much more clear. All right, so as I said, first what we have to do, we have to create the map. So map of int comma int will create, right, and we'll iterate inside the array and form this map. For auto element inside of our array, we have to put these elements inside of the map. So now my map is created. Now second step is to create the priority queue, right? So min priority queue is what we are going to create. So create min priority queue. Now how do we create min priority queue in C++? So the syntax is, you simply write priority queue and first you write the value that you are going to insert inside the priority queue. So that is pair int comma int. Then because this is the, if you simply write it like this, right, simply write it like this, then it is a max priority queue by default in C++. But if you want to create a min, so you have to pass 2 more parameters here, which are vector, and inside of this vector you have to insert the value that you have taken here, that is pair. All right, so after you create the vector, you have to also pass this greater function, and again inside of this greater function you have to pass this pair, right, the element that you are inserting inside the priority queue. So that is the syntax to create min priority queue in C++. So you can also remember this blueprint. You have to insert the value, then you have to take this vector and you have to create vector of this value. Okay, so here in this case it was pair, and then you have to take this greater function, and inside of here as well you have to pass the value that you are inserting inside of the priority queue. So remember that. So to create min priority queue, value, vector of that value, and creator of that value. So this will create a min priority queue for us in C++. After this, we have to create this priority queue. We have to put values inside this priority queue. So that we will be taking from where? From the map. So we'll go and iterate inside of our map. Now, as we discussed, the pair is going to store the frequency first and then the element. And we already discussed why, because frequency has to be inserted first, as the frequency matters to us, right? We have to do operations according to the frequency. We have to remove elements according to the lower frequencies. Correct. So what we'll do, we'll push the first frequency, right? So for frequency will be in it.second of the map. So it dot second is the frequency and it dot first is the element, right? So this will create my priority queue. After my priority queue is created, I have to iterate while k is greater than 0. Now inside of this loop, what I have to do, I have to first take the top element. Okay, so I have to take the top element from the priority queue. So I can simply say top pq.top as the top element. After that, I have to take the first value. You can also use top element to get first and second values, or you can also write your own, take variables and then do it. So I can say int f is equal to uh, top element dot first, and we can take element as top element dot second. Okay, and after this what I have to do is I have to remove this, right? So I have to pop this element from this priority queue. After removing the element, right, here we saw what we have to do. We have to take this element out, and we took that element out, and we also took the frequency and the character out. And after that we have to remove this from the priority queue, right? So removing it from the priority queue, after that we have to perform the operation. So what is the operation? First I have to check if k minus f will be greater than or equal to 0. If so, then simply do k minus equal to f. That is, you removed all the frequency of this particular integer from here. Otherwise, let's say k minus f is less than 0. I said make k is equal to 0 and put the remaining frequency with that element inside the priority queue back. So I'll say pq dot push, and we have to take f minus k, right? Because now k is less than f and the integer, so element is the integer. So after this while loop, what will happen is we would have removed all the frequencies, lower frequency elements from the priority queue, and we would be left with the least number of unique integers that are still inside the priority queue. And we saw that priority queue size is going to return us those elements. So I can simply return pq dot size here, and that's it. That's all that we have to do. Now let us quickly run it and see if it works. Okay, so this is working, right? Now let us discuss what is the time and space complexity. So the space complexity, you can already see we are using a map and a priority queue. So for that we are using, so at most n elements can be there, right? So big O of n will be the space complexity. If we talk about time complexity, so here the time complexity will be big O of n, that is the number of elements inside of the array. Then here the time complexity would be big O of n for iterating inside of the map, and for this push operation inside the priority queue log n. Okay, so it will be n log n. All right, and after this we are iterating in this k, so this is nothing but simply k time complexity, right? So this is big O of n plus n log n plus k, right? So obviously k will be definitely less than equal to n, so the total time complexity will be n log n in this case. So the time complexity is n log n and space complexity is big O of n.